Cool, brilliant, thank you. Okay, yeah, thank you for having me. Sorry I couldn't be there in person. Um, I'm giving a nano talk, so I know it's 5 minutes, so I'll try and keep to that time. And I think Tony really laid the groundwork very well for this. But yeah, I'm just here briefly to talk about the Push It project and our involvement in it. There's a presentation later in the day on Push It as well, so I won't spend too much time talking about the project in general. But this is a Horizon Europe funded project to explore high temperature underground thermal energy storage in three different sort of technology areas: aquifer thermal energy storage, borehole thermal energy storage, and mine thermal energy storage. There are three sites that are completing full-scale implementation of each of these technologies. Bochum is the one for mine thermal energy storage, and that's what you'll hear about later. But there are also three follower sites who are in various stages, kind of running from feasibility to pilot study, which are kind of learning from these full-scale implementations. From that, we are the follower site for the mine thermal energy storage at United Downs. We're conducting a feasibility study to examine the potential for coupling that technology with our high temperature resource from our deep geothermal plant. So I've presented, I think, in posters about this before, but broadly the kind of idea here is that this is like a current status on the left-hand side of this diagram, where we've got this deep geothermal power plant up and running now. We're utilizing temperature from brines pumped from an open hole section of our well from just over 4 kilometers to just over 5 kilometers depth there, pumping to the surface, generating power. And more recently, we've developed a lithium extraction plant on site here at United Downs. However, currently, we are not utilizing kind of heat either directly from the resource post power production or any waste heat generated on site, of which there's quite a lot through an ORC plant. And we're sort of exploring that separately. But then also we've got this potential there for heat storage. So in some ways with this feasibility study, we're trying to get ahead of the curve for utilization of that heat in the future, but then also understand how you may integrate it with these kind of geothermal systems to kind of tool ourselves in the development of future projects. Very similar map on the top right there that Tony highlighted in his talk, which is just the sort of location of mines across Cornwall and into Devon up there in the east. And the key thing with our geothermal projects at United Downs is we wanted to develop a model that is kind of repeatable across similar sort of geological conditions across the county. So this kind of broad spread of kind of now abandoned and flooded mines kind of adds it as a potential option to many of our sites. And in fact, we utilize all the sort of data collected in all our subsurface mine plans and things like that to tool our exploration for our geothermal sites. So the two work well together. So the feasibility study, I should mention we're into the last year of the project now. So I'll kind of touch on which pieces of this is done, but hopefully next year you'll be hearing kind of the full presentation on this. But largely what we focused on is bringing ourselves to a level where we have explored the kind of technical, financial, and then regulatory sort of feasibility of development of this project in the area around United Downs, and then also explored how we would incorporate sort of community and other stakeholder engagement of these kinds of projects into our pre-existing engagement around critical minerals and deep geothermal. Similarly, as mentioned by Sally in her talk, a lot of time has been spent looking at mine plans, putting together as much pre-existing work and data as possible. And then this has been supplemented by our own field work running throughout the length of the Push It project. This has been done quite closely with the BGS. And we've been constantly monitoring water levels in shafts. We've taken numerous samples to monitor the geochemistry of these fluids. And again, touching on what Tony said, some of these are pretty low pH and quite metal rich. And then also, again, taken downshaft temperature and conductivity profiles to both to feed into our modeling, but also to hopefully understand flow and interconnectivity across the shafts and any potential stratification. Regarding modeling of these systems, we are beyond the conceptual model. We're building up a 3D hydrological model for the area, which doesn't really exist currently. So we're trying to incorporate kind of the geothermal developments, both ours and shallower works in the area, with the mine workings and other hydrological features. We're modelling specific scenarios for mine thermal energy storage, again with the BGS, that particular piece of work. And we've also done some modelling with another project partner, BRGM, on sort of geochemical models of these specific systems and how we'd integrate it with our geothermal plant as well. So last slide, in brief, as I say, because it's a nano talk, and Tony touched on a lot of these things. But we evaluated all the sort of mines in our local area, and there are kind of 4 key mines that are located in close proximity to our site at United Downs, and assessed them for potential for being selected as our kind of target mine, and consolidated mines won out. This is in part due to technical reasons, such as kind of environmental concerns with other mines, or access reasons, with us having either agreement to access the land and access open shafts, but also just the pure number of open shafts available to access. However, this is a really large, complex, interconnected mine that's been amalgamated from other small mines at various different points in its history, which leaves a lot of uncertainty and a lot of complexity. From an access point of view, we kind of evaluated where these key shafts are located and how we'd best sample and collect data from those. So that's been great, but all that data collection has been very focused on those kind of single accessible shafts, especially those that are kind of deepest in their present day condition, are either aren't blocked or haven't collapsed. So again, it kind of limits our data collection into these specific areas. Regarding the 3D model, we can kind of get around that by utilizing these old mine plans and kind of obviously, I guess, making some assumptions into their present day condition and looking at different scenarios. However, the decision was made that when it comes to the modelling of these mine thermal energy storage systems, the modelling would focus specifically on single shaft scenarios. Not only did this reduce kind of uncertainty around the connectivity and size and the sort of heat volumes we were looking at in these kind of large systems, there was also precedent in the area with Mount Wellington mine water geothermal project, which Tony mentioned, being located just down the road, to act as a really good point of comparison. It alleviated some of the concerns around the geochemistry of the fluids in this particular mine, because again, touching on Tony's talk, these were copper mines, and there's some pretty nasty mine water compositions there. But it also allowed us to produce, hopefully, what will be a model that can be utilized to fit other. So although we're using data from shafts in our specific mine system, we can utilize it kind of county-wide and in similar shafts in the area. So hopefully we'll produce something that's kind of, as useful as possible going forward. Thank you for your time. I don't know if we're doing questions for the nano talk, but I'm happy to answer any, or feel free to email me, and we'll go from there. Cheers.